Okay, so here we're starting chapter 2, this is 2.1, which is comparing and ordering rational numbers. Notice the word ratio here. A rational number is any number that's a ratio. And a ratio can be written as in fraction form. For example, 3/4, or decimal form, such as 0.75. Remember, a decimal and a fraction, or some things about fractions. A fraction is made of a number we call the numerator over top of the denominator. And in a fraction, a denominator can never equal 0. So in 2.1, we have to work at ordering rational numbers. For example, from least to greatest. The common reminder here is to look at a number line, and on a number line, we have something like 0, 1, negative, -1, -2, -3. And we are to place some rational numbers on here. Here at 1.5, here at -2 1/4, maybe up here at -2/5, or at -1 1/3. These are some rational numbers that are ordered on a number line. And here we have the numbers getting larger, and here we have the numbers getting smaller. And so we have them, -2 1/4 is a smaller number than -1 1/3 as we're as we're ordering those. So let's do a little example. If we had say 3/8, 1/2, 9/16, 4/5, and let's do another one here. How about 12/16 also. So if we had to order those from smallest to largest, what is their technique? Well, at first, if you're not really used to rational numbers, you could convert them all to the same form. And what we mean by that is a common denominator. And we'll work on that example, and then later I'll show another way to get this same form. So if we were to look at a common denominator between 8 and 2 and 16 and 5 and 16, see, I'm going to change this just to make our example a little easier. I'm going to make this a 16 right away. Okay? So if we put all of these numbers over 16, okay? So if we would change this one and this one so it would also have the same denominator as 16. So you remember how we do that? If we have 3 over 8, then that equals how much over 16? And we realize to get from 8 to 16, we multiply this by 2. And so we know we can also multiply the top by 2. Okay? So 8 times 2 is 16. 3 times 2 equals 6 over 16. So this 6 over 16 is called an equivalent fraction to 3 over 8. These are equivalent to each other. They're equal fractions to each other. We could do the same thing with 1/2. 1/2 equals how much over 16? And forget from 2 to 16, we multiply that by 8, but we'd also multiply the top by 8, and you end up with 8 over 16. And so these are also equivalent fractions. They have the same value. And I want to just point something out here. In each of these cases, we multiplied our first fraction by a number that was over top of itself, either 2 over 2 or 8 over 8. And if you realize 2 divided by 2, this equals 1, and 8 divided by 8 equals 1. Whenever we multiply something by 1, the answer stays the same. So when we multiply by 1, we do not change the value when multiplying by 1 or a form of 1, like a number over itself. So that's why these are equivalent fractions, because 1/2 times 1 still equals 1/2. It's just in a slightly different form, but 8 out of 16 has the same value as 1/2. So now, if we put these in, if we would insert these into the above here, so now 1/2 is the same as 8 over 16, and 3/8 is the same as 6 over 16. Now, because these are all out of 16, we could more easily put them in order from least to greatest. So here we have the smallest one at 4 out of 16. And here we have the largest one at 12 out of 16. So if we were to order these from smallest to largest, we might start with 4 out of 16. And then we would look at our next one, which is 6 out of 16. And our next one would be 8, 9 out of 16, and then 12 out of 16. So by putting them with the same denominator, we put them in the same form, and now we can order them from smallest to greatest, from least to greatest. Okay? Let's look at another way to change numbers to the same form. And I think most of you will like this one a little bit better. Same form could also be convert to decimals. This one is probably a little more attractive to you, but you should also make sure that you can still do convert to fraction form and the denominators. You need to be able to do both of these in grade 9. So if we were to convert to decimals, again, if we were to make up a bunch of fractions, say 2 out of 8, 3, 5, 9 out of 16, 1, 4, 3 out of 14, and so on. So if we were to these and convert these to decimal form, I'll just go 2 divided by 8. So this line here means divided by. So 2 divided by 8 is going to equal 0.25. And 3 divided by 5 is going to equal 0.6. And 9 divided by 16 is going to equal 0.5625. And 1/4 is 0.25. And 3/14 is 3 divided by 14, which equals 0.2142857. 1/4. At least that's as far as my calculator reports it. So now if we were going to order these from lowest to greatest, we'd realize we've got 2 of them here that have the same value. And they are not the smallest, because this is a little bit smaller. 0.214 is smaller than 0.25. So if we were to order these from smallest to largest, we would put it as 3 over 14, and then we would have 2 over 8 and 1 over 4, kind of at the same spot because they're equal to each other. And then we would have 9/16 is a little bit smaller at 0.56 and 3/5. So then we'd have 9/16 and 3/5. So there we would have fractions ordered from least to greatest. Maybe have a little example of this. If you were going to spend $5 at one store for 3/4 of a kilogram of, say, sausage, and at another store you were going to spend $5 for 7/8 of a kilogram of the same sausage, and at yet another store you'd spend $5 for 13/16 of a kilogram, and at a fourth store you're going to spend $5 for 2/3 of a kilogram. Would we be able to calculate which of these stores you would have the best buy? The blue store, the green store, the red store, or the black store? So if we were to order these, of course, the more that you can buy for $5, the better deal that you're going to get. So you might be able to do a little bit of this in your head. You realize that 7 over 8 is 14/16, and 3 over 4 is 12/16. But let's go through the process of putting these all in the same form. And so this here, just to have a look at it, this, if we multiply this times 4 over 4, that's going to equal, right, because 4 times 4 is 16 on the bottom, and 3 times 4, that's going to be 12/16 of a kilogram. Here, 7/8, 8, we multiply that times 2, we must multiply the top by 2 as well, and we end up with 14/16 of a kilogram. And this one is already at over 16, that's 13/16, and 2/3 doesn't easily go into 16, so we've got a bit of a problem here. But if we just put it over 15, maybe that could help us get close, and maybe not. So if we put it over 15, it might help us. So if we multiply this times 5 over 5, we end up with 10/15. And so that's going to be very close to 10/15, or that is 10/15. That's going to be very close to 10/16 as well. Maybe about 11/16. Okay? And so by estimating a little bit, we should be able to realize that this 2/3 is the smallest. Okay? To verify that, we could also convert these to decimals. Because when we have a weird one like this, 2/3, that doesn't easily convert to a common fraction, it might be more simple to go to a decimal. So some of these common fractions, maybe we realize to a decimal here, 3/4 is 0.75, and 7/8 is 0.875, so that's larger, and 13/16 is 0.8125, so that's a little smaller than the 14/16. And 2/3, perhaps you realize, is 0.6 repeat. So if we were to order these from our Best Buy, okay, so this is our number 1 choice of the store. This is our number 2 choice of the store. This would be number 3, and this, you would be paying the most money for the least amount of sausage at that store, at our black store. There are some good examples of these explained in our textbook on page 49 on equivalent fractions. They're pretty similar to how I'm converting them, so that we can get a common denominator so that we can compare. Just a little bit of review. I think if you remember that if you were going to convert decimal fractions, and I'd encourage you to always put the fraction in simplest terms. And I'll show you what I mean by that. If we had a decimal of 0.4 and we had to put that into fraction form, I think you perhaps know that this 4 is in the 10th spot. So this is 4/10. This is 4 out of 10. Now, we can maybe recognize that 4 is the same as 2 times 2 if we were to put it into factored form. And on the bottom, 10 could be written as 2 times 5. So if you notice, we have some factors that are common to the top and the bottom. And so whenever you divide, because this line here means divide, whenever you divide these numbers by common factors, we can just cancel them out. If they're factors of each other, that means we're multiplying them together. Not if we're adding or subtracting, just if they're factors multiplied. So 4/10 in simplest form, when we take 2 out of the 4 and out of the 5, we end up with 2/5 as a fraction in simplest form. So one of the things that we need to do at the beginning of this chapter 2 is to find a rational number between two other rational numbers. Okay? And so a rational number is most often, okay, just as a fraction or written as a decimal. So if we had to use the example from the book on page 50, they're suggesting we find a rational number between 0.6 and 0.7. And again, they're urging you to look at this as if it were on a number line. And so if we had a number line, and this is actually, they use negative 0.6 and negative 0.7. So if we put this at being 0, and this at negative 1, then kind of halfway here would be negative 0.5, and each of these little spots here, we would divide into, try to make this as even as I can. And so we've got negative 0.6 and negative 0.7. So if this is negative 0.5, then right here is negative 0.6. This spot here, and this spot here is negative 0.7. So any of these places between here on the number line are going to be between negative 0.6 and negative 0.7. So if we come halfway between negative 0.6 and negative 0.7, say right here, doesn't quite look halfway, but it's close enough, then we realize that we're at negative point. You should always put a 0 here, because you should never have a bald decimal, they call it. So put a 0 here in front. Negative 0.65 is a number that's directly between that. And I'll show you how we can verify that that's true. If we were to order them 0.6, 0.7, and 0.65, is this indeed between these two? Well, this here is these were negatives, right? So these are negatives. So it's pretty clear that this 0.0 or 0.65 is right in between these as we look at the different values of them. We don't really need to kind of convert them. That last screen might have been more confusing than useful, but at least we could see that 0.65 was right between those other two. Here are some questions that you should maybe work on. So 2.1 assignment. Okay. To get a C, you should work on some of those skills, and you should do questions 4 to 17, do letters A and C. And that 4 through 17 is on page 51 and 52. And to get a B, I'd like you to work on questions 18 to 26. And assignment B, or assignment C above. And to get an A, I'd like you to do questions 28 to 30 and B and C above. And those are on pages 51, so I think all the way over to page 54. Page 54. I'd like you to have these questions due for December 5. We're moving our schedule back a little bit as we took an extra day to kind of prepare for that test. So if you could have those questions due for December 5, that would be ideal, and we should be maybe ready for a quiz for that Friday, December 5.